And good afternoon, everyone. Today, I'm going to talk about this end-to-end framework for the ergonomics risk factor quantification using a single wearable sensor. And this slide lists all the students and collaborators working on this collaborative project. And let's see if I can, I can move the slides. So this is the outline of today's presentation. I will first motivate on why we studied this problem, and then talk about the proposed framework, and then I will demonstrate with the electrical line worker study, and finally conclude the presentation and talk about the future work. So this study is focusing on the risk analysis for the electrical line worker. So as reported by some references, it is one of the most top 10 most dangerous jobs in the US. And it's because of there is a minimized staff, there is usually workers are working in the harsh environment, so on and so forth. So what we are trying to propose is that given that we know the workers are usually work alone or with a small team in the remote environment, and usually they are having some heavy burden tasks, we try to propose and promote this wearable sensor-based approach so that based on the sensor of the user or the worker's information and based on the analytics of the sensor, we can timely infer what is happening in the field while people is working on the task, and then we may, based on the sensor, to tell whether people is fatigued or not, and analyze the risk. So that is what we are trying to achieve in the long term. And for this study, the objective is to perform the ergonomics risk assessment based on only a single wearable sensor, like one on this wrist of the operator. And the challenge is that the sensor, well, is lightweight, but did monitor the continuous work activities during the operation. So we may have the noisy information during all the time that people are wearing the sensor. And the initial sensor also tend to lack the context of what is performing, the worker perform of their task. And so we want to extract the information on the task and also count, identify the task, count the duration, and assess the risk. So here shows a demonstration of our proposed framework. So on the top is we call the stage one, which is offline training. So we get some baseline experimental data, and then we train some classifiers so that we can tell what is people doing, such as like pushing the cart, climbing the ladder, working on the electrical panel. And on the second stage, on the bottom, we want to propose some real-time analysis tool so that on one hand, we can segment the observation so that while people is continuously working on some task, we know what is the specific task people are working. And then based on the offline trained classifier, we can classify the actual type of the task people doing. And then we can count, say what is the number of the replications, what is the expected number of the times people have been doing a certain task, which will be fed to the like classical ergonomic risk assessment tools for the risk assessment. So here is a quick view of our experiment like simulation environment. And we in total ask the subjects to do the 10 tasks listed in this top of this slide. And in the bottom shows our summary of the like our operator recruited simulated operators, and the people wear a single Impacta E4 wristband during their operations. And for our offline training, we select 80% randomly from all the participants for the training of the classifier. And we use basically CNN convolution neural network to classify the operators' activities. And then for the testing, we use the remaining 8 subjects to perform the task segmentation, identify what is the activity based on the trained classifier, and then based on the activities, we further count the replication and then perform the risk analysis. So in the next couple of the slides, I will show you the results in the online implementation phase. So here in this slides is the segmentation part, in which based on the sensor, a single one wearable sensor information, we first perform the segmentation. So here you can see on the top is if we just use this graded Gaussian segmentation blindly, you can see we have a lot of small segments. Say here, the highlighted red and blue boxes are actually very similar area. You can see they should belong to the same task. So we did perform some correction so that we do not overcount the number of replications. And then a second correction that we made for the segmentation is we know like for some task, people may have some variation, like say the vibration of the hand, that may lead to a change in the segmentation. But actually, after we do the classification, they may belong to the same class. So our second part is to combine this into the same class. So that yields to the final segmentation. So you can see among these corrections, we can have a very good segmentation result. And then we feed the segmented results to the classifier. So we have a pretty accurate classification. And then we can count the number of the replications. And due to the sake of the time, I will just show this risk analysis results. So it's pretty accurate. And in summary, we test in a single wearable sensor. We can perform the segmentation, classification, and counting of the task, and we can perform the risk analysis for the electrical line worker. And in the future, we will have some field experiment to validate the proposed work and have the alternative sensor or approaches to the analysis of the data. Thank you.